Hello, honors. I don't know, it's very upbeat today, apparently. So we're going to be still reviewing. So we're going to be reviewing solving inequalities. So let's get to it. That's going to be in chapter 1, which is 1.5, solving inequalities. Okay. So before we actually get into solving inequalities, I'm going to review interval notation, which we have talked about. Sorry, excuse me. Bless me. Okay. We've talked about interval notation with domain, and now we'll just kind of like, if you haven't seen it in Algebra 1, kind of will be a nice little refresher here. So hopefully you've seen it. If not, here it is. Okay. So there are two different ways that we can write things in interval notation. Actually, let's start by heading this. Okay. So two different ways that you can write intervals. You can either use brackets or parentheses. So brackets signify closed interval. Like that's kind of like how we say that. That would be a closed interval. And what that means in like layman's terms is that the solution includes the starting number, which I'll explain hopefully that even more in a minute. So closed interval means the solution includes the starting number. So inequalities that are closed intervals are less than or equal to or greater than or equal to. So it's with that or equal to factor that's making it a closed interval, which is what I mean when I say the solution includes the starting number. So if it's x is greater than or equal to 3, your solutions are 3 and everything else that's greater than that. So it includes that like first number. Okay, so it includes less than or equal to or greater than or equal to. Now, parentheses are for open intervals. And an open interval basically means that the solution includes everything up until that number. Up until that number. So in inequalities, we use open intervals for less than or for greater than. So if I said like x is less than 3, my solutions to that are every single number that's less than 3 but does not equal 3. So it's like 2.99, 2.999, 2.99999, but it's never 3, which is, when we're talking about excluded values, that's why we use parentheses there, because what's happening is those graphs, those functions that we're looking at, they're trying to get extremely close to that point. So it's, if the excluded value is 5, it's working at 4.99, it's working at 4.99, 4.999, but it can't just get to 5. So that's why we use the parentheses to signify when we're talking about excluded values. Now, infinity is a big one when we're talking about interval notation. And so let's talk about that. So when using infinity, we always use open intervals. So like if your domain, let's just bring it back to domain. If your domain was all real numbers, the way that we would write that in interval notation, because all real numbers is essentially every number between negative infinity to positive infinity. So we'd write it like that, negative infinity to positive infinity. That was a terrible infinity sign, sorry. Okay, so let's look at some examples. And then or not examples, but let's talk about a little bit more about interval notation, and then we'll do some examples of inequalities. Okay, so I'm gonna do like a little chart here. So we're gonna write out some inequalities. And then we're gonna write the graph. And then we're gonna write it in interval notation. Okay. So if I were to write 4 different inequalities, so x is less than 6, x is greater than 6, x is less than or equal to 6, and then x is greater than or equal to 6. So you probably know how to graph these. Now, a lot of times we use an open circle. Sometimes we use something that's different than an open circle or a closed circle. Sometimes we actually use parentheses and brackets. So let's look at that to kind of like familiarize ourselves with that format. So if I were to graph x is less than 6, so my point is at 6. And instead of using an open circle, I'm going to use just a parentheses, and then it's going in the less than direction, so in the negative direction on for infinity. Now remember, and I stand by this, I think the graphs really help you guys in writing something in interval notation. So if you're stuck in how to write something in interval notation, look at a graph, like draw it on a number line, and then use that to help you. Because to write this in interval notation, I'm looking at the green and I'm thinking, okay, it's going on for negative infinity all the way up until 6. It doesn't equal 6, so we're going to use an open interval. We're going to use a parentheses. So the way that we would write that is negative infinity to 6. Always use a parentheses on infinity, and 6, it's less than, so it's not, or equal to, so we use a parentheses on that one as well. When you guys are writing stuff in interval notation, always write it from least to greatest. Okay, let's then look at x is greater than 6. So if you're feeling good, you're feeling confident, I want you guys to graph that one on your own and then write it in interval notation and see how you do. Okay, you should be coming back. You should be graphing x is greater than 6. At 6. It's greater than, so it's going in the positive direction, but it's not equal to, so it's still that parentheses going in the positive direction. So in interval notation, we're always looking at it from left to right. So from left to right, it starts at 6 and goes on in the positive direction forever. So in interval notation, that would be 6 to infinity. We use a parentheses because it can't equal 6. We use a parentheses on infinity always. Okay, so x is less than or equal to 6. So when we do that, still at 6. So less than or equal to, always we're using, like when it's that or equal to, we use brackets. So less than or equal to is going to be a bracket going in the negative direction. Now, how do we write that in interval notation? So again, we're looking at it from left to right. So from left, it's going in the negative infinity direction forever. So we're going to start with that. That's easy. It's always a parentheses. Then it goes up until 6 and it hits 6. It's equal to 6. So that means when we go to 6, we use a bracket. Really similar to the one above, but instead of using a parentheses, it's a bracket. Okay, last one. X is greater than or equal to 6. I want you guys to try that one on your own, see how you do, and then come back, make sure you did it correctly. Okay, so I would graph my number line. It would be at 6. It's greater than or equal to, so it's going in the positive direction. it's that or equal to, so we're going to use a bracket in the positive direction. And then to write it in interval notation, I'm looking at it from left to right. So we start at 6 and go in the positive direction for an infinite amount. And that is interval notation. Okay, so a little bit about the difference between equations and inequalities. The difference between equations and inequalities is the number of solutions. An equation has a specific set number of solutions. Typically it has 1, sometimes it has 2, sometimes it has 3, but there's a set amount of solutions for an equation. Whereas an inequality, x is less than 6, that's my solution. Well, there's an infinite amount of solutions for that inequality. So the difference, let's write that, because that's important. My handwriting has just not been great lately. Okay, so the difference between equations and inequalities is the number of solutions. So inequalities have an infinite number of solutions. Have an infinite number of solutions. Now, before we get into examples, let's talk about our last most important thing about remembering solving inequalities. It's like the golden rule of inequalities, one of the most important things that you guys cannot forget with solving inequalities. So let's write that one out. And some of you know it off the top of your head, and some of you are like, inequalities, huh? And that's okay. That's what I'm here for. So the rule of inequalities, and I bet you if you don't remember it, once I start saying it, you will remember it. It looks a little blurry, I feel like. It looks a little blurry. Let's try and focus. Oh, that feels so much better. Okay, so the rule of inequalities is when dividing, and then maybe that light bulb went on, when dividing or multiplying, both sides, it's important that both sides of an inequality by a negative number. Now, if the light bulb hasn't gone on now, you're like, oh yeah. I don't know. You must flip the inequality symbol. Don't worry, we'll do examples. You must flip the inequality symbol. Okay, so let's get into some examples. The math part, the fun part. Okay, so examples, and again, if you guys have any questions through these, ask me in class. We can talk about them. We can laugh about them. We can, I don't know what's happening. It's Saturday and I'm making a video. This is how I spend my weekends. So, okay, so let's try one. 2 minus 3x is less than or equal to 5. Okay, first step in solving. We all know it, and we're saying it out loud. Mr. Imperio, the first step is to subtract the 2. You would be right. So I'm going to subtract the 2 from both sides. 5 minus 2 is 3. And now to solve for x, I need to divide both sides by -3. Now, hopefully you're thinking, wait, we're dividing by a negative. And remember, when dividing or multiplying both sides of an inequality by a negative number, you must flip the inequality symbol. So if I divide both sides by a -3, that's going to become x is now greater than or equal to -1. Let's write that down so we don't forget why we flipped that symbol here. My pink is running out. It's okay, I have an extra case. I just have to open it somewhere. So you need to flip the inequality symbol. Because both sides were divided by a -3. Oh no. I think that pen is going to have to come up sooner than I was hoping to. Update, I opened the new pens, so I'm ready. Okay, so we solve for x. Now our last step is to write it in interval notation. So I'm going to first just graph it. You're not going to have to graph it. That's not super important to me, but I'm going to graph it to help us to remember how to write it in interval notation. So when we graph it, x is greater than or equal to -1. So greater than or equal to, that's going to be a bracket because it's that or equal to, and greater than is going to be going in the positive direction. And so when I write that, we're starting at -1 and going on in the positive direction forever. So the way that I would write that in interval notation, it's hard to write when it's at the bottom of your, I'm going to try. Just like move things around here. So it's going to be bracket -1, comma, infinity, worst infinity. I mean, it wasn't bad. It's just crooked. So look at me hyping myself up over here. Not really hyping myself up. That's your answer. So your answer is not the, like, I don't know what this form is called, but it is not this form. Your answer is interval notation always. So when you guys are doing the classwork and you're entering this in for into formative, your answer should be an interval notation or else it's going to be marked wrong. Okay, let's go on to 2. I'm going to fold the page because I like to be right. I feel like this video is picking up on all of my like weird idiosyncrasies. I think that's the right word. Now it's just like you guys are like, she's full blown crazy. Okay, so -3, 1 minus x is less than or equal to 12. 2 ways of doing this, and I don't care how you do it. You can either first just divide off that -3. You'd have to flip the inequality sign, but then we'd end up doing that twice. So what I'm actually going to do is I'm just going to distribute the -3 to get rid of my parentheses. Oh, new pen vibes, the best. So -3 times 1 is -3, and -3 times -x is positive 3x. Okay, I want you guys to finish this problem on your own. Pause me here, try the rest. You got this, and then come back and check your work. First step, we just added 3 to both sides. Then I just divided both sides by 3. And then we're going to write it in interval notation. If you guys don't need to graph it and you don't need to see this visual representation, by all means, don't do it. You can just go and write it in interval notation, which is what our final answer is going to be. So less than or equal to 5 or equal to is that bracket going in the negative direction. So to write it in interval notation, we're going from -infinity to positive 5. Infinity always has a parentheses. And then the 5, because it's or equal to, has a bracket. And that is my final answer. Okay, we are just going to do a few more examples, and then we're going to do 3 more. That's what I'm prepping you for, 3 more examples. Okay. So number 3, let's make sure we get there. Okay. Number 3, we have 3x plus 4 is greater than or equal to, or not greater than, sorry, just greater than 1/3 x minus 2. First, make sure you have it written down correctly. So make sure you have that written down, because the worst thing would be to like follow my steps and then have the original problem starting off be incorrect, and then you get the wrong answer for the wrong problem. So, okay, so what would I do here? So think about what you do first. How would you make this easier on yourself? And I would, to make this easier on myself, and if you are still not ready and you want to pause me, but to make this easier on myself, I would first start by getting rid of that fraction. I don't like to deal with fractions. I know you guys don't like to deal with fractions. So an easy way to do that is if I have 1/3, what I'm going to do is I'm going to multiply this side by 3. Now, if I multiply this side by 3, I best be multiplying this side by 3 also, because whatever you do to one side of an inequality or of an equation, you have to do to the other side. Now, the reason why I multiply this side by 3 is because what's going to happen, 3 times 1/3 is 1, it cancels, and so the fraction's gone. So 3 times 3x plus 4, that is 9x plus 12. And then what happens, 3 times 1/3 is just 1, and I'm left with just x minus 2. Now, why don't I have to multiply it in here? Because that would be double the multiplication. If you had already distributed this 1/3 and then multiplied it by 3, you'd get to this end result also. So now we just solve it. So I want you guys to pause me here. I want you guys to solve this one on your own, graph it. You don't have to graph it. Get it in interval notation. So get it in interval notation. That's going to be where your answer is going to be. Okay. First thing I did is I subtracted x from both sides to get 8x plus 12 is greater than -2. I then moved the 12 over. I subtracted 12 from both sides to get -14. And to get x by itself, I just divided both sides by 8. So now what I would do is simplify my fraction. So those are both divisible by 2. So x is greater than -7/4. We can always check in our calculator if that's as simplified as it can go. If you plugged into your calculator, oh my God, -14 divided by 8, I just put in an extra plus. And then again, you change it math frac, it will give you the reduced answer always. So -7/4 is our reduced answer. Okay, so let's write that in interval notation. I am going to graph it just to help us to make sure we know how to graph. So we have -7/4. It's greater than, so that means it's a parentheses going in the positive direction. So to write that in interval notation, we're going from left to right. So -7/4 to positive infinity. And that is my final answer. Okay, that was fun. Let's try another. 2 more, then we're done. Okay, so my next one is x minus 1 times x plus 1 is greater than x minus 3 times x plus 4. Okay, so I want you guys to think, what would be your first step in going through this process? So what would be the first thing you would do? And if you said to distribute or multiply it out or FOIL, whatever you want to say, you would be correct. So we're going to do that. X minus 1 times x plus 1, that's going to be x squared plus x minus 1 is greater than x squared plus 4x minus 3x minus 12. Now you're thinking, how am I supposed to solve a quadratic inequality? It's okay. Let's keep going. So I'm going to combine my like terms. X minus x actually cancels, right? X minus x is 0. So I'm just left with x squared minus 1. And then 4x minus 3x can combine to become 1x. And now I would start to just solve it like I normally would. And what ends up happening is I would start to combine my x squared. If I did that, I would want to move this x squared to the other side. And what happens, x squared minus x squared is 0. X squared minus x squared is 0. The x squareds go away completely. So I have negative 1 is greater than x minus 12. Now, easiest step here to solve for x is just to add 12 to both sides, which is what I'm going to do, but then we're going to talk about what that means for our answer. So when I add 12 to both sides, negative 1 plus 12 is 11. And this is opposite of how most of my inequalities are written, where the x is on the right side instead of the left side. So the inequality is a little bit flipped. And so what we need to do is we need to look at it instead of what direction is the inequality facing? Is it facing towards the x or away from the x? So when I write it in a normal way like this with the variable on the left-hand side and the number on the right-hand side, what happens when the, since we know the inequality symbol is not facing the x, we're gonna have it not face the x, and so it flips. When you rewrite it in a different, when you like flip the order, you flip the inequality symbol also. So now we can write that in interval notation. If we need to graph it, we can graph it. It's greater than, it's less than 11. So less than 11, we're using a parentheses because it's not equal to, and it's going in the negative direction. So that means it's going from negative infinity to 11. And it's a parentheses on the 11. Okay, last example. We're going to spice it up a little with a compound inequality. So a compound inequality is when we have two inequality symbols. So if I have two inequality symbols on each side, to solve for x, when I do that, so first step when solving for x is to, and hopefully you're saying subtract 2. And you'd be correct. So we'd subtract 2, not only from the middle, but from both outsides. Because really what this is just like two inequalities. So we have to do it to both sides. So that gets me 2 is less than or equal to 2x, which is less than or equal to 8. Keep going to solve for x. We would divide both sides by 2. Now that means everything gets divided by 2. So 2 divided by 2 is 1, less than or equal to x, which is less than or equal to 4. Okay, now this is where I really think graphing helps. And sometimes if you guys need to break this up into 2 parts, then you guys can break this up into 2 parts. Because what this is 2 inequalities, like with restrictions on it. An example of like a compound inequality in real life would be like, I'm trying to think of something. I mean, it's essentially saying like you have to be between, like if I were to say to, attend this school, you have to be between 14 and 18. And so that's a compound inequality. It's like where there's a restriction and you're between those two values. And so this is what this one is. So what it is one of them is it has to be less than or equal to 4. That one's kind of the more straightforward one. But with this one, it's kind of like what we saw with number 4, where it was backwards, where the x is on the right side versus the left side. So it's x is greater than or equal to, because it's facing the x is greater than or equal to 1. So let's write that, or let's graph that. So it has to be greater than or equal to 1. So greater than or equal to is that bracket. And less than or equal to 4. So again, another bracket. Positive in the 1 direction, negative in the 4 direction. So then to write that as an in interval notation is actually really easy. It starts at 1 with a bracket and ends at 4 with a bracket. And that is your answer. And that does it for inequalities today. So hopefully that was a little bit of a review from Algebra 1. If you guys have any other questions that you want to clear up, please bring them to class. We can go over them. And that's that. I hope you guys have a great day, and I will see you guys soon. Bye.